Okay, let's begin. Me again. Who wasn't in the room for the last talk? Okay, a few people. Cool. Okay. Who wasn't there? Never mind. Okay, so I'm going to talk Kubernetes. After talking ECS for the last hour, I'm going completely schizophrenic and talking about Kubernetes, and we're going to contrast and compare and get very hands-on with Kubernetes and our new EKS service. So let's start. That's a good sign, isn't it? Some of my slides have already got pictures broken. PowerPoint came up with a lovely error just before I started presenting here, so that picture of me has been redacted for some reason. It's probably best. I've got a face for radio. Okay, so for those of you that weren't in the talk a minute ago, I'm Paul Maddox. I'm specialist at AWS, focusing on developer technology, so serverless, containers, DevOps, etc. Have a long history of development background and AWS certifications and a lot of development experience mainly. My Twitter details and email details are there. Feel free to contact me. For those of you that were in the talk last time, sorry for the repetition there. So what are we going to talk about today? This talk was originally built to be generic Kubernetes, running Kubernetes on EC2 in a self-managed fashion. I'm actually going to change this. I rewrote the talk last week. We're going to dive deep on EKS and talk about our new managed Kubernetes service. We're going to get hands-on. We're going to deploy some containers. We're going to deploy some clusters, and hopefully give you a chance to ask questions around what Kubernetes in EKS actually looks like, how it works, etc. So we're going to run through some deep details on how the master nodes and etcd are going to work and how do upgrades work and visibility, etc. Because we're going to be focusing on EKS heavily like this, this isn't going to be a talk that tells you, should I use Kubernetes or should I use ECS, right? That's a topic for another day. We're just going to talk about Kubernetes and EKS in this talk due to time constraints. So first of all, why is AWS doing a Kubernetes thing? So interesting stat here by the Cloud Native Computing Foundation. They did a survey last year. 63% of Kubernetes workloads run on AWS. It's pretty interesting, right? Until very recently, this has been a self-managed thing. All these customers go in their own route. Who here runs a production Kubernetes cluster? Okay. Who runs a non-production Kubernetes cluster? Yeah, more people. Just waiting to make that jump. Okay, so this is pretty interesting. What this tells AWS is we've got a lot of customers going through the same things, deploying their own clusters, managing their own clusters, and there was an overwhelming request from the community for us to get involved and make people's lives easier here. So if you've been managing Kubernetes clusters on AWS yourself today, there's a really nice option. KOps, COPS, whatever you want to call it. It's a CLI tool that deploys good Kubernetes clusters onto AWS. Makes it simple, works with infrastructure as code, etc. The thing is, when you actually start using it, there's still a fair bit to do. So just to deploy a Kubernetes cluster on AWS, you need to get the tooling set up. You need to do things like create an S3 bucket where COPS keeps all of its state and configurations. You need to configure DNS or deploy a gossip-based cluster. This is still a really good way of deploying Kubernetes on AWS, but it's not as seamless as our customers want. Overall, customers, the general message was, Amazon, please just carry the pager on this one for us. Like, we don't want to run this. Mainly because it's not just about the deployment of Kubernetes, right? It's the ongoing management, monitoring, high availability, productionizing of Kubernetes that customers find challenging. I think it's okay if you've got a large engineering department. We have people like Ticketmaster and Zalando run huge Kubernetes workloads on AWS. They also have huge engineering departments to look after those Kubernetes clusters. Same with things like Monzo, etc., that Abby was talking about earlier. So definitely, Amazon, just run Kubernetes for me. Oh man, it looks like all the images in my talk are broken. This is, I've got some diagrams. Okay, this talk may be interesting. Okay. We'll roll with it and see how we get on. Okay, Okay, so we're launching this service. It has got a nice logo. You're going to have to trust me on that. Great logo, probably the best logo you've ever seen, but you'll never know now. So EKS, a managed option for Kubernetes on AWS. So there was a lot of speculation before Reinvent around this. We launched the announcement at Reinvent. It's in preview at the moment. You can sign up for the preview on our website, put your details in, and we'll get you preview access as soon as we can. I can't talk about any dates, etc. here today. You know, people want to put their hand up and say, when can I get it? When can I touch it? I'm afraid I'm not going to be able to answer that question today. Hopefully I can answer all your other questions about it technically though. So when we started building EKS, we had a couple of core tenants. So first of all, we wanted EKS to be a really good place for running production workloads with Kubernetes. So we want to take away the hassles of monitoring, high availability, backing up, scaling, etc. of your Kubernetes clusters from you. We want to make sure that best practice is instilled by default. Number two, a native upstream Kubernetes experience. So a lot of customers were concerned, or certainly when I've been speaking to customers and saying, hey, Amazon, what's going on here? Like, are you just forking Kubernetes? Are we going to end up with some, separate fork of Kubernetes that's got a whole load of Amazon-specific stuff in? And actually, if I want to run my workload in Kubernetes somewhere else, is that going to be a problem? Is that going to be a struggle? The answer is categorically no. We're not forking Kubernetes here. This is upstream, main, open source Kubernetes. There is a whole load of stuff we want to do to Kubernetes in general to make it better for customers on AWS. But we're going to be upstreaming that back into the open source version of Kubernetes or into open source plugins. So anything you can run in EKS and the managed offering, you should be able to run in Kubernetes on AWS as well, or Kubernetes elsewhere. Okay, so anything we do here is going to be committed back to open source. Number three, a lot of customers want to see better integrations with AWS in Kubernetes in general. So there's a lot of heavy lifting if you're running Kubernetes today around things like IAM, security, etc. Some of the integrations into AWS are not ideal at the moment. And this is one of the main reasons we joined the CNCF, right? We want to be able to have a seat at that table. We want to be able to influence how Kubernetes works behind the hood. And we want to ultimately make it better for AWS customers to run on AWS. So we're going to be doing a whole load of work. We've already started contributing to a load of open source projects to make this better. I'm going to be covering some of those as we go through here, if my diagrams permit. Okay, number four, actively contributing back. I kind of covered that. So I want to say that this is a slide that when I click next, all the instances are going to appear in my architecture diagram. This is awkward. Okay, so here is almost what a good practice Kubernetes cluster looks like on AWS, just missing the actual architecture. So we've got a couple of availability zones here. Each availability zone in AWS is one or more data centers separated by low latency. You typically have master nodes. Okay, these are the actual schedulers that are receiving your pods and your containers and saying, hey, where on the cluster can I run this container? And what happens when it dies? You then have an etcd cluster. And etcd is used by Kubernetes as its state management store. So where it keeps track of what your cluster looks like, where all of your pods and stuff are, it's the persistent store. And these sometimes can be run on the same instances, so the masters and etcd. Some companies prefer to split them out separately. And then at the bottom, you have your tier of worker nodes. And this is where the actual workers are deployed into. So these are the instances that run your containers. So this is what a Kubernetes cluster looks like today if you run it on AWS, kind of. All we're doing really is taking those top two tiers, the master nodes and the etcd nodes, and wrapping them up into a managed service. So if you were in my previous talk, we talked a bit about the shared responsibility model and where the line of delineation appears in terms of what you're responsible for and what we're responsible for. With EKS, Amazon are responsible for the master nodes. We're responsible for etcd. We're going to run those, maintain, scale, manage, monitor, etc. The master nodes and the etcd cluster. The worker nodes are going to be your responsibility still. But we're going to provide tooling to help make that easier for you and manage that. We're going to expose, when you create a cluster, an API endpoint So this is like a standard HTTPS Kubernetes API that your workers and tooling and kubectl and stuff will connect into. So what does the actual service look like that we're providing, the EKS API? Actually, it's really, really simple. This is a pretty boring service and API in terms of how we make it visible to you, and deliberately so. Boring's good, right? So the EKS API has 4 endpoints. It's your basic CRUD API. Create me a new EKS cluster, describe an existing one, delete one for me, and list the ones I have. This is a key design choice for us. Ultimately, we want you to deploy your Kubernetes clusters and then manage them using Kubernetes primitives. So instead of using things like security groups, etc., we want you to be able to use network policies within Kubernetes. We want you to be able to use RBAC within Kubernetes, configure your authorization, authentication, etc. So the bulk of the configuration is not done in EKS. It's done in your normal Kubernetes tooling. And this is actually great because this provides you options and portability, right? The less that's configured that's EKS specific, the more portable your workload is going to be. So let's talk a bit about how EKS is actually architected behind the scenes, what it's doing. The first thing we're going to talk about is the master nodes. What is the master node configuration? So these master nodes are not going to be deployed into your AWS VPC, etc. They're not going to be EC2 resources that you see in your AWS EC2 console. This is more of a managed service similar to RDS or something, whereby you deploy your cluster and behind the scenes it spins up the instances for you. So we're going to be deploying an auto-scaling group spread across availability zones. So this auto-scaling group of masters is going to scale up and down automatically and transparently to you. So we're going to be taking into account things like how many pods you're running, how many worker nodes you're running. Like if you look in the Kubernetes documentation, there's fairly standard guidelines for if you're running this many workers, then you probably want this many master nodes, etc. So we're going to be scaling those master nodes in and out for you transparently. You're not going to see downtime, etc. when that happens. That's going to be done behind the scenes transparently. So you get this highly available auto-scaling fleet of masters and etcd configuration for you there. Next question a lot of people ask here is, what about versions? What about upgrades? How do I manage those master nodes? So with EKS, we're going to be supporting a certain number of Kubernetes versions. So we're probably not going to go back to the beginning of time and support every possible Kubernetes version out there. And it's going to be a rolling thing. So we'll likely support like the last couple of versions. So when you create a cluster, you're going to choose the version of Kubernetes you want to deploy. So you pick your version. Any minor updates that come, like if you look at the Semver versioning of Kubernetes, any minor updates that come, we're going to apply those automatically to your cluster. Like you can do it manually, we're going to apply them automatically for most people. When it comes to the main versions, the major versions of Kubernetes, you get flexibility and control there. So automatically, you can choose to set up automatic updates, so we're automatically going to take you to the next version. Or you can set it up to be manual so that you manually upgrade. Maybe you find that something doesn't work with the latest version of Kubernetes within your architecture. You get control and flexibility there to be able to pin a certain version of Kubernetes. At some point, that version of Kubernetes, if you don't upgrade it and don't upgrade it and don't upgrade it, is going to go out of line of what we support, right? We're only going to support the last couple of versions, and you'll get an email notification similar to EC2, for example, like planned maintenance. We're going to forcefully update your cluster, or you can go in and do it manually before that period of time. Okay, so the key thing here being is we're only going to support the most recent couple of versions. Next question a lot of people ask is, how do I get visibility, right? This is a managed service. Managed service normally comes with a balance of convenience versus control, etc. So what can I actually do with these master nodes? You're not going to be able to SSH into them. There'll be no way to actually SSH in and get a terminal on these master nodes, for example. You are going to be able to get visibility on what's going on them. So things like all of the kube system pods, we're going to be centrally aggregating all of the logs from those pods into CloudWatch logs for you. We're going to be providing metrics into CloudWatch metrics around what's going on your masters. But ultimately, you're not going to be able to SSH in there. That kind of ties on to the next slide here, which is, okay, maybe today in Kubernetes, I want to run add-ons on my masters. Like there are certain processes, monitoring tools, things like Prometheus, etc., that I want to run on my master nodes. How do I do that, Amazon? So we are looking at the way of allowing you to provision Kubernetes add-ons at the time that you deploy a cluster, like tick a box, I want that add-on on there. That list isn't finalized yet. Like this service is still in preview. We're still working out with customers that are in the preview, what they want to see there, etc. If you have any feedback about add-ons that you use today on your Kubernetes masters, let me know. Now's a good time to influence that roadmap still. So master nodes, we're looking into ways that you'll be able to deploy those. That's still undecided in full detail, to be honest. There's nothing stopping you putting add-ons on the worker nodes in Kubernetes. Like the worker nodes are your responsibility. They're just EC2 nodes. So you can install whatever you want on there in terms of monitoring agents, etc., kube to IAM, stuff like that. So how do you provision these worker nodes? I'm going to show you and actually give you a demo of provisioning a cluster in a minute. Ultimately, these worker nodes, we're going to do a similar thing to we do with ECS, whereby we're going to publish a Kubernetes best practices AMI. Have an SNS topic that you can subscribe to when there's updates to that AMI. That AMI is going to have Kubernetes in it. It's going to have everything needed to connect it up into the EKS cluster. We're actually going to build that with HashiCorp's Packer. So if you want, you could actually not use our AMI, build your own using the Packer scripts that we're going to publish. So heavy focus on open source here, a lot of transparency. We're also going to be providing a CloudFormation template that's going to allow you to just load up this CloudFormation template, say I want 10 workers, run it. And it's going to create those workers for you and attach them into your EKS cluster. Again, if you're something like a Terraform shop or you use Ansible or some other tooling, there's nothing stopping you taking that logic out of CloudFormation and putting it in insert tool of your choice here. Any questions so far? Kind of around the master node? Yeah.
Sure. Will you be able to actually use kubectl to, say, get the logs or actually list the services you run on your master, like the API server, the schedule?
I haven't tried it. Let's try it in my demo. Why not? Yes.
Will you be able to set the flags on the API server?
I don't think so first launch. So kind of tied to that is support for like alpha APIs and stuff. We're not going to be supporting alpha APIs at launch. It's just going to be the stable APIs and stuff. But in terms of the flags there, I'm not sure. Let's talk more about the use case there and we can talk through options. Okay, let's talk through networking and how networking is going to work here. So this is pretty interesting. Like, if you've used Kubernetes on AWS before, there's a plethora of networking options available to you. Right? Things like Calico, things like Flannel, Weave, etc., all trying to provide this overlay service that allows Kubernetes to spin up an IP per pod and route all of the traffic between all the pods. Nearly all of the solutions out there today are not ideal. Like, it's always a trade-off with these solutions. Quite a lot of them create overlay networks. Often with overlay networks, you've got added complexity, you've got added overhead in terms of performance. Things like Calico came out to try and get away from that complexity. So with Calico, every pod gets its IP address in the Calico network. But still between availability zones in AWS, you're going to be doing like tunneling and encapsulation and stuff, and it's not ideal there. So we sat down and thought, how can we do this better? If you've seen the ECS networking, the new ECS task networking, this works in a very, very similar way. So we published a CNI plugin. CNI is the pluggable architecture for networking within Kubernetes. So Kubernetes won't actually assign an IP address to a pod. It basically offloads it to this plugin architecture, and then you plug in whatever network plugin you want. So we've created a network plugin, an open source one on GitHub, the URL's there. And it basically does VPC native networking for all of your pods and containers. This isn't limited to EKS. You can run this on your own Kubernetes clusters today. It's completely transparent, portable there. It's not EKS specific. So this is pretty cool because your pods and containers just get given a native VPC IP address, There's no overhead of overlay networks. There's no translation or natting or bridging between different subnets, etc. If you want to diagnose and try and follow a network packet through the path of your network across hosts, etc., you can just use ping and traceroute and like TCP dump and stuff. There's no natting that you've got to work through, etc. But key here is that you don't get that performance overhead as well. So we just get out of the way, every pod gets its own network interface. And it looks something like this, which may or may not work because the okay, oh God. Okay, so we've got some pods that we're deploying. So we've got an Nginx pod, also had awesome icons, you're just gonna have to trust me on that. We've got some Rails pods, they come up. The CNI plugin here, represented by this nice, easy to understand blank circle, goes away to the EC2 networking backplane and says, hey, EC2 networking, can I have a network address, please? There's network interfaces, ENIs, on your Kubernetes hosts, and we deploy a whole load of ENIs to your hosts, and we deploy a whole load of secondary IP addresses on those ENIs as well. So then what's going to happen is your pods are going to get assigned one of these IP addresses. And if I want to communicate from this container here and talk to a container over here, I can just address it natively and just use its native IP address. So really, really simple networking. Encourage you to have a look and have a play with this. There is one side effect to this, though, one limitation to be aware of. Security groups. So with AWS, security groups, firewall rules, etc., they're applied at an ENI level. You can see here we're using secondary IP addresses on each ENI. So that means every single one of these pods using this whole ENI with all those IPs is going to get the same security group. So typically not granular enough for most container workloads today. So as part of the release here, all right, the animation works, but none of my pictures work, brilliant. Part of the release we've been doing here is working with Tigera. And they created like Calico and the network policy plugin, the main network policy plugin that's used on Kubernetes today. So network policies, again, not an EKS specific thing, but we are porting them to EKS. So you'll be able to use them in EKS, allow you to define rules in like a YAML manifest that say, okay, my dev namespace in Kubernetes can never communicate to my prod one or vice versa. Or my applications of this selector type can only talk to my database server on 3306 or whatever. So you get this really fine-grained abstraction over network control and policies. So actually the recommendation, if I go back to my previous slide, and we look at these ENIs and security groups, etc., the recommendation and the way it's set up out of the box is these security groups in AWS will be pretty open. Any container instance should be able to talk to any other container instance on any network port. And you use the network policies to actually define who can access what and your application level details. This is kind of nice if you are running Kubernetes somewhere else. Another cloud provider, on-prem, for example. This means that your network control policies are done at an abstraction above the provider level. They're a Kubernetes primitive here. So you're not going to be writing security groups for one cloud and, I don't know, another one for another cloud or something. I put a link at the bottom there to a page I found last week that actually has some really nice example recipes of different types of network policies that you can put in place. So I want to do it based on namespace, or I want to do it based on service, etc. So recommend checking that out when you're writing network policies. A whole load of examples there. You might not have to reinvent the wheel. Next question I get a lot is, what about security? If you've used Kubernetes today, typical provisioning experience for Kubernetes, if I'm a developer and I want to use kubectl, kubecontrol, kube, however you want to pronounce it, if I want to use the Kubernetes CLI and deploy stuff, I generally have to be provisioned onto a cluster, right? Someone's got to give me a config file that contains my tokens or certificates so I can actually access it, right? My kubectl config file. That can be a bit painful in a large enterprise or large organization where you have lots of developers. You don't want to have to go and provision each user manually, etc., for kubectl. So this is one area we thought we could improve and do a bit better, and actually integrate kubectl with IAM directly. So if I'm a developer and I've got AWS credentials on my laptop already, That should be good enough to talk to Kubernetes, right? I shouldn't need to go through any additional provisioning steps. At the same time, if I'm running a CI/CD system or something, Jenkins or code pipeline, code build, whatever, in AWS, and it's running on EC2 instances, I should just be able to assign that a role, and that should be all the permissions it needs to be able to talk to my Kubernetes cluster. So part of the service that we're releasing is actually a modified version of kubectl that works with IAM integration. Now, today in the preview, this is a pre-compiled binary that we ship you as part of the preview. That's not the long-term plan here. We will be upstreaming this back into kubectl so that it's the default experience for everyone. They can just brew install kubectl or whatever. So that's one side of IAM. And basically the way that's going to work is you've got your command line interface here. It's going to automatically pass your AWS identity into Kubernetes. Kubernetes is going to use an open source plugin that we've been working on with Hept.io. So again, this isn't specific to EKS. You can use this today on Kubernetes, self-managed on AWS. It's going to talk to a plugin represented by this missing picture here, which is the Hept.io Authentication plugin. It's going to go back. So that's going to do authentication. So this person is who they say they are. The other bit you need to do is authorization to say, I know this person is who they say they are, and I want them to be able to do these actions within my Kubernetes cluster. So for the authorization side, you're just going to be able to use role-based access control, so standard RBAC within Kubernetes. So again, just bring in more of your configuration data up to the Kubernetes abstraction level, which was a big ask from our customers. Any questions around authentication, etc. there? Before we sort of dive on? No? Okay. I'm going to take that to mean I either explained it really well with my lack of pictures or people just don't care about authentication. I'm not sure which I'm more comfortable with. Okay. So, roadmap. Where are we going with this? So, a lot of this I spoke about these worker nodes. Having to deploy these worker nodes with CloudFormation and Packer scripts, etc. yourself, that's not the long-term goal. Long-term, we want to make things easier for customers. We want to get customers away from having to manage any infrastructure at all, patching any infrastructure, etc. A lot of our ECS customers were super excited or are super excited about Fargate. We want to bring the same thing to Kubernetes as well. So Fargate has been designed in a way that it's not tied to a particular orchestrator. It just provisions resources to run your containers at the last minute. So great way of deploying containers. It's not there today with EKS. I don't have any timelines on when it's coming, but the team are working super hard on bringing Fargate to Kubernetes as well. We have an open source Kubernetes Workshop. Has anyone seen this? This is a really, really good resource. So a load of the open source and Kubernetes team within AWS basically spent a couple of months building what we think is the ultimate Kubernetes hands-on learning workshop on GitHub. So this is a GitHub repository. When you go to it, it's got a whole load of topics. Things like creating a CI/CD pipeline, service meshes, service discovery. They're kind of loosely coupled into the beginner, intermediate, and advanced sort of leveling. So from the beginning one is like create your first cluster with KOps, for example. Right up to the advanced, like using ingress controllers and stuff. This is a really, really good learning experience, especially if you like bringing on new people, new engineers, and you just want them to learn about Kubernetes on AWS and best practices, etc. Completely free, open source. If you want to see anything added to there, all of these workshop modules have been developed in an open source manner as well. So if you look in the GitHub issues page, you'll see all the stuff we want to add here. Right? You can pick something up, do a pull request, submit it in, and have your eternal fame and glory as your work is now in our Kubernetes workshop, or something like that. Okay. So yeah, recommend checking that out. We'll share the slides as well afterwards if you didn't get a picture of that. So I just wanted to show you so far. So this service is in preview, I should caveat this with. Okay. So this is the EKS console. It's very, very simple. I showed you that simple API, right? I told you about our design tenant of making it as simple as possible to configure Kubernetes, and then you do all of your configuration within Kubernetes. As a result, this isn't going to be the most interesting of demos. So I got a cluster I created there. When I want to create a new cluster, give it a name, original demo 2. Pick my Kubernetes version. Now in this preview version of EKS, it's just got 1.7. We haven't bothered bringing it up to the latest level because actually it doesn't affect our preview too much. When we launch this serverless service as generally available, you can obviously expect to see the latest version there. I specify a VPC ID. So where do I want my container instances to be, which VPC? And then I need to create a role. So in the preview at the moment, there's a CloudFormation template that you get given that provisions like a default VPC and a default role that's suitable for EKS. I don't know, I imagine this is going to be a nicer experience when the service actually goes live. So this is like early access preview I'm giving you here. Okay, so I can go and create my cluster. If I go back and just show you what an existing one looks like, again, super simple. I get my API endpoint. This is my Kubernetes endpoint there. I can hit that and actually see the Kubernetes API. And yep, I'm not authorized, but the Kubernetes API is up there and running. If I go into okay, so normal experience, if I run kube control, get nodes. This isn't going to work. This is going to be the experience that you're going to get if you try and connect to an EKS cluster today without using our patch binary that has the IAM authentication. So I've actually got the patch binary on my machine. Kube control, get nodes. Okay, so this is authenticating with IAM, and it's going to go away to my Kubernetes cluster and get my nodes, and you can see them all there up and running. So the other part that you get when you join the EKS preview is a second CloudFormation template that's going to deploy the nodes for you. So if I actually go into my CloudFormation console, you can see here I've got these two CloudFormation templates. The first one that deploys the IAM role and VPC, and then the second one that I can run multiple times that actually deploy the nodes for me into my cluster. So I've provisioned 3 nodes already, and I could do like, for example here, I've got a descriptor file that just deploys an Nginx service with a load balancer in front of it. So Kubernetes is going to automatically create an ELB for me. There are other options, by the way, if you want to use other load balancers. The ALB, there's an ingress controller written by Ticketmaster and CoreOS for the application load balancer that you can use. We've also been working with a few people on the support for the network load balancer, the NLB. And we see the NLB as being the default really going forward, so that's our goal here. So NLB integration, I think it's included in Kubernetes 1.9. But that's probably going to be the default option for most people going forward rather than the classic ELB. So I've got a service here that's going to deploy an Nginx container. It's going to deploy a load balancer in front. Here you can see I define my container. And then I've got a volume mount that actually mounts an Nginx config. So here, right in the configuration, I'm just setting my Nginx configuration. So I can go away to my EKS cluster and do kube control, apply Nginx. Okay, that's deployed my service, my deployment, my pods. I should be able to get the pods. Okay, so I can see my pods up and running there. It's pulled the container, my service is up and running. If I do get services, okay, I can see I've got a service here created. It's got an external load balancer created. If I go in my AWS console and go to, come on, EC2, I can see, okay, in my AWS account, I've got my worker nodes. So back to my previous point earlier, you're not going to see your master nodes in your AWS account. You're not going to see your etcd nodes, etc. They're part of the managed service. What I do see here is my worker nodes that were spun up by that CloudFormation template. If I look in my load balancers tab, I can see that that deployment I've just done has created for me a load balancer. behind the scenes, I can see that it's connected it up automatically. Kubernetes has connected that up to my load balancer and to my instances. I can see it's out of service at the moment. That initial registration takes a couple of minutes, and I hoped myself talking about the EC2 instances would distract you while it did it, but it hasn't. There we go, we've got one in service now. So if I just take the IP, the host name of my load balancer, pop that in a browser. Okay, in a minute the DNS is going to be provisioned. It normally takes about 2 or 3 minutes there, but that load balancer will come up and I'll be able to access my Nginx service. So this may not be the most interesting demo because this is just Kubernetes. Like, if you take one thing away from this whole talk, the experience with EKS that you're going to get is just open source Kubernetes. Right, we're going to be making it better and adding things in with network policies and all that kind of stuff to make it better to run on AWS, but it's just open source Kubernetes, and actually that's what our customers have been asking for. Okay, that's it from me. Any questions? I'm going to go over here. I'll come back to you in a sec. Yes, sir.
Are alpha features enabled?
No.
Is there any way to enable it?
Not at the moment, not in the preview. I suspect the team are listening to requests there, but the feeling is at the moment that this is a managed service that we want to provide and we want to lock into some level of stability. Therefore, alpha Kubernetes APIs are not going to be included in the managed service. Yes?
What about log aggregation? Long-time logs. Do you have any kind of managed abstract or equivalents in there?
Okay, so the question was log aggregations, manage health checks, etc. How's that going to work? So I guess you mean on the master nodes, or?
In general. All the containers, they come and go. I want to see the logs.
Okay, so yeah, at the moment today, the integrations are the standard integrations, right? So your container logs, Kubernetes is automatically going to pull them back. I can do things like kube control, get logs, for example, for a particular service or a particular container. So Kubernetes is already pulling those logs back in. I think it will depend where you want those logs to go. Like integrations with CloudWatch logs could be something that we work on. Not sure. I think it will depend on your specific requirements, but Kubernetes by default has that power of centralized logging built in. Yes?
So, getting back to working typically on EC2, the amount of CNIs and the amount of private IPs you can get on the CNIs is subject to limitation depending on the instance size that you're getting.
Yep.
Is that going to work exactly the same way with EKS? So, say I want to deploy 20 containers, I want each of them to have a private IP, but is that a different limit or is that the same limit that EC2 actually has?
It's similar but slightly different, and I'll explain why. So the question was around ENI limits. Okay, so the networking here, if you're using the CNI plugin for AWS networking, it uses ENIs, Elastic Network Interfaces. There are limits to the number of ENIs today that you can spin up on instances, and it depends on the instance size. So with ECS, for example, if you're running it on C4, 8x larges, you get 8 ENIs. Now in ECS today, that means 8 tasks, or 7, because one of them's the host ENI.
You get a certain amount of private IPs on each ENI.
So today in ECS, it doesn't use those.
Okay.
Today in ECS, it just uses the ENI, like with the primary IP address. With EKS and actually the CNI networking plugin for Kubernetes, it actually can be a bit smarter there about that. So it uses multiple IP addresses. So you get, it's basically the first number times the second number. So if I'm running on, I don't know, what's a common choice, like M4 large or something. If I'm running on an M4 large, I get 2 network interfaces. Each one can have 10 IP addresses. That's 20 pods. So you are subject to that limitation. Bear this page in mind when you're creating your clusters and choosing your sizes. It will have a direct correlation to how many pods you can run. It's something we're looking at improving over time as well, right? These limitations obviously are coming up more and more in conversations now that we have this task-based networking for ECS and this CNI plugin for Kubernetes. So that is something that we're hearing loud and clear, but these are the limitations today. This is specifically this design choice of using multiple IP addresses in the Kubernetes networking layer meant that we have to use network policies, or you can, are recommended to use network policies in Kubernetes because of those security group. It's applied at any ENI level. So, Yes.
You said when we configure the master node, they don't go in our VPC. They go in an invisible VPC, right? But in the page where you were showing how to configure the master node,
Yep.
you actually specify your VPC ID.
Yeah. Good question. So the question was, when I was talking about these master nodes, I said they don't specifically run in your VPC. They run in a managed VPC. So they don't appear in your AWS EC2 console, etc. But when I actually, in the demo, went and deployed a cluster, it had a field asking me for which VPC. And the reason for that is we introduced something called private link. Do you see private link around reInvent time? So private link allows AWS services running outside of your VPC to appear inside your VPC. It basically creates network interfaces within your VPC. So that's why, because your masters need to talk to your worker nodes. Right? Your worker nodes need to communicate with the masters, etc. You probably don't want that to be over the internet. So therefore, the Kubernetes cluster, the masters, appear in your VPC via that private link functionality. Yes?
What's the maximum number of 5,000 like Kubernetes?
Yeah. So we're paying attention to the recommendations done by the various SIG groups in the CNCF. So the current recommendation is like 5,000, as you say, for 5,000 worker nodes. So we're working towards that. As and when, like there's talk at the moment of them upping that to 10,000 worker nodes. As and when that happens, we'll make sure EKS works with that as well. So yeah, this has been designed for scale on our side. We're going to be, as I said, scaling up and down those masters based on the number of worker nodes you have and other factors. So yes, you can run very large clusters on us if you want. At the back. So the question was, will there be any integrations between config maps in Kubernetes and KMS for encryption of secrets within those config maps? I'm not aware of any being worked on at the moment. Love to, like, if that's something you'd be interested in helping with and working with us on, love to. Happy to carry on that conversation. I'm not aware of it being worked on at the moment. That said, it does seem like a very logical choice, so I don't have more detail at the moment. Okay, thank you everyone for your time. One more. Go for it, shoot. We've got time.
So currently for ECS tasks, for example, you could in fact just use CloudFormation to define your limits on resources and so on and so on. And EKS to start with, it looks like it's a fairly simple API, just create a cluster. Can you share a bit of information, if you can, of course, whether CloudFormation support, closer to EKS is coming up?
So deploying Kubernetes pods with CloudFormation, is that the question? Yeah, I actually saw some email traffic on this on one of the email lists internally I'm on recently. I believe that open source Kubernetes Workshop we were talking about may have a section on deploying pods and Kubernetes resources with CloudFormation now. EKS Workshop, let me just double check. I'm pretty sure, like, I saw some mention of it. CloudFormation. Let's pick that up afterwards rather than making everyone sit and watch through it. But to answer your question, yes, it's being worked on. If it's not in this now, it will be very soon. Yeah. Thank you very much for your time, and thanks for listening.